Methylation is involved in not only making DNA, but regulating DNA in immune cell synthesis and regulation, in neurons and neurogenesis and maintenance. I mean, it's such a fundamental compound, this carbon with 3 hydrogens. It infiltrates everything.
Welcome to this week's Wellness Wednesday. And this week we got another excerpt from the Fatigue Super Conference. This is from my interview with Dr. Kara Fitzgerald, and we are talking about the role of methylation. Methylation is something which is quite complex. I think this clip is quite technical in places, so maybe more relevant to the kind of practitioners among you. But methylation is really the body's process by which we switch on and we switch off different bodily processes. It's particularly interesting in the context of DNA and genes, something we touched on in last week's episode with Dr. Ben Lynch. So in this excerpt, Dr. Fitzgerald is just giving us a bit of an explanation of what methylation is, why it's important, and some of the conditions and areas that we can see impacts of methylation working well or not working well. So here is Dr. Kara Fitzgerald. Let's get a bit into the topic we're going to talk about today, which is DNA methylation. And maybe for those that are kind of thinking, what the heck is DNA methylation? Maybe give a bit of context of that, but also why it's so important to the fatigue population.
Mm-hmm. Absolutely. So DNA methylation, a lot of people have heard of methylation. Methylation is a methylation cycle in the body that's happening, buzzing along all of the time and really virtually every cell in the body, making a carbon with 3 hydrogens. That's just one of the most fundamental molecules in the body that when placed on a different molecule or taken off a different molecule can really change the behavior of said molecule. So we can make neurotransmitters, for instance, we can metabolize neurotransmitters. Thinking about fatigue patients, of course, we're going to make adrenaline and noradrenaline. We're going to, synthesize dopamine. So a lot of our neurotransmitters produced and metabolized via methylation. We detox compounds. We clean our bodies up. Methylation plays a big role there. The methylation cycle interfaces with something called the sulfuration cycle. And the big player produced in that cycle is glutathione, our main endogenous antioxidant. I'm sure the folks in your world are thinking quite a bit about increasing glutathione. And you have to have healthy methylation. You have to have active methylation to be doing it. Methylation is involved in not only making DNA, but regulating DNA in immune cell synthesis and regulation, in neurons and neurogenesis and maintenance. I mean, it's such a fundamental compound, this carbon with 3 hydrogens. It infiltrates everything. Our conversation today, we sometimes in my world talking about this will distinguish from biochemical methylation, which is detoxification, making and detoxing neurotransmitters, etc., and then genetic methylation, sort of these two worlds. It's a false distinction, but it just helps us wrap our hands around or what's a complex concept. So in DNA methylation, specifically, methyl groups are placed on our DNA, and when a sufficient amount of methyl groups are on a particular gene, it shuts that gene down from expressing. Conversely, we can have regions of our DNA that are not methylated. So it's hypermethylated when something's got a lot of methyl groups on and it's shut down, or hypomethylated when it's undermethylated and that gene is turned on. Now, so we use this to regulate genetic expression. This is where the environment interfaces with gene expression, what's going on. DNA methylation is a huge, huge piece of it. And I bet you can get, Alex, that there's all sorts of opportunities for, negative environmental influences to alter gene expression. And one of the big places would be right there. I want to say one more thing and then I'm going to stop. These epigenetic, it's called epigenetics, these epigenetic methylation patterns are actually heritable. So what you have right now, you could pass down to your offspring. Are you biased towards health or are you biased towards disease? I mean, it's really kind of as simple as that. And there's interesting research, demonstrating this. Lots of animal studies demonstrating this heritable aspect of DNA methylation. And then there's something called for people who want to look at, long-term human studies, there's something called the Dutch hunger winter, where during World War II, the people in Netherlands were starved for a period of time. Women who were pregnant actually handed down epigenetic patterns to their offspring that carried forward through generations. Yeah, and so increased risk of obesity, of cardiovascular. Wow. Yeah, and so it's heritable within generational, but also in the generation of cell turnover in our body. So we're cleaning and changing epigenetic expression all of the time.
I want to come back to that a bit more in a bit because that's super fascinating.
I just kind of unpacked it. Unpacked a lot there, but yeah, go ahead.
So just to help people kind of get a bit more of a handle on this, what are some of the clinical issues which you would say are associated with methylation imbalances?
Yeah. Okay. So what aren't? I would actually put it like that. And I can give you a little bit of the background. I don't want to be too kind of alarmist, but the reason that it became there's two reasons it became so interesting to me. One is that, in functional medicine, we're always thinking about methylation. We tend to be thinking about what I call biochemical methylation, where we're wanting to detox and we're supporting methylation that way, or neurotransmitter synthesis, or just tending to our central nervous system and thinking about methylation there. So we tend to want to push it forward. Oh, actually, the other huge issue, of course, is single nucleotide polymorphisms. Anyone can send off some saliva and have back a whole lot of methylation genetic data and decide that they're not good at methylation because they've got maybe an MTHFR polymorphism or something along those lines. And people can become really anxious, and there's a lot of content on the internet talking about these massive methylation protocols that people should adopt, sort of anchored in taking a lot of B12 and folate, or, in addition, like betaine or certain amino acids, or, there's a host of nutrients involved in the methylation cycle. So all sorts of protocols will just really ramp it up. That doesn't take the DNA methylation, this genetic methylation, really into consideration. So the massive aha for me as a physician was when I started to read the data, and most of the science in DNA methylation comes from cancer research. And we know in cancer research that methylation is really imbalanced there. Good tumor suppressor genes can be hypermethylated and shut down. Sort of bad oncogenes that promote cancer can be hypomethylated and turned on. So we can have this really skewed picture of methylation expression that allows for the pathogenesis, the promotion of cancer. And there's just a ton of research out there on that. And so I think when I started to metabolize it some years back, that stopped me in my tracks. And me actually and the director of my nutrition program, Romilly Hodges, kind of stopped us, and we really sat down and started combing through the literature. And then we developed this whole methylation diet and lifestyle program that we're going to talk about here in a few minutes. And in fact, we're researching it. So it's proof of concept right now. We're actually in the middle, towards the end of a big epigenetic study. So we're looking at methylation changes in this program. So cancer was where a lot of the research first came out, but you can see it in any chronic condition. I mean, even in acute conditions. And you could see sort of biases or vulnerabilities inherited. Cancer, cardiovascular disease, autoimmunity, certainly, the ME/CFS, really kind of, you name it, allergic disease, schizophrenia, PTSD, low stress, alteration to the stress response can be inherited and can be based on these epigenetic changes, autism. So it's really kind of what isn't influenced by this.
I hope that clip was interesting. If you want to go deeper into this area, the full interview is available as part of the Fatigue Super Conference. You can still buy access to the recordings. Tomorrow it's Thoughtful Thursday, and I wanted to build on some of what I talked about in yesterday's Therapeutic Tuesday in the second session with Katrina, where I was talking about sometimes when we come more back into the body, we actually can see an increase in anxiety. So I'm going to do a session tomorrow exploring 3 different types of anxiety and how to identify perhaps which type is happening, and that can be its own pathway to knowing what to do to help resolve it. So I look forward to talking with you tomorrow on Thoughtful Thursday here on Everyday Alex.